Thanks for your fantastic talks. I think we might have a few more questions from the audience, but I'll start with a sort of a very general question, and Konstantinos already alluded to it as very hard to predict the future. So kind of returning to the topic of this workshop, Transformers at Work, will we have a Transformers at Work workshop next year again? Or will it have to be called something else? Are we stuck with the Transformer? Who wants to have a stab at that?
So the prioritization of Transformers seems to be crucial. Maybe I'm saying something wrong here, but people try in the past with recurrent neural networks. It doesn't scale that well. So I think it's, if we can still stuck with this parallelization scheme, we'll be seeing more and more, at least transformer-like structures in the future. Yeah.
So, as you said, predicting the future is really hard. What I would say is that there's a line of work from Chris Ray's group at Stanford using state space models that I do think is really promising, because it allows you to use RNN type models, but where you can still have high degrees of parallelization. So there's a promise there that you might get really good scaling. That's the only thing I've seen that feels like it could be a successor.
Yeah, I think that the only argument against transformers has been this quadratic attention, so quadratic number of memory and compute when you scale it. And so we are like these 512 limit, where people say, yeah, RNN is nice, you can scale it nicely. But now with flash attention, that's more a problem of the past. And I mean, it's a really cool thing that you can look at every token, at every step, every compute step. And I think that's like really, really hard to beat. And RNNs don't match with that. So, but I think next year we will have transformers, but at some point equip it with a world model or so, because transformers are really shitty at really basic things like math, like adding two numbers, multiplying two numbers, reasoning, and so on. So here I think they are not a good fit. And when we want to go to AGI, I expected that it can do addition of two numbers.
So maybe to add one thing, I completely agree with what these guys have said, but maybe so this has become broader and broader each year, right? So more applications of the transformer and bigger transformers. Maybe next year you could invite also people who actually look into the transformer, so not broader and broader, but deeper and deeper, so that we can start to learn to understand why they are so powerful. Yeah, you have to organize it.
So I'm just the humble organizer, and we like to not only have great talks at the cutting edge of what's going on, and you never know where that ball is going to be. So we're here to facilitate and help you discover that future. And we're also here to throw a party. So don't go anywhere just yet. I think Transformers for having a good party, I have not read any papers on that yet. So
maybe picking up on that transformer architecture dominating, and then moving into more models with more agency, so things that can actually accomplish goals and understand that they've accomplished a certain goal. Where do you see that heading? Because we have a lot of different approaches now, just in the language model space, but also in robotics. So anyone?
More VLMs? No, I mean, but jokes aside, one interesting direction would be, for example, to use, at least in robotics, right, to use a VLM to be able to tell you whether you're there or not. So instead of providing, showing the goal like you showed Julia do, saying, well, is the red cube on top of the blue cube or something like that, right? And then the VLM maybe can score that the image that you have kind of automatically for you, and that is a huge problem. You're right, kind of like having reward models, I guess, or like success detection. I don't know how you look at it. It is a huge problem, and that would be a direction. But other than that, it's an active research direction, I think.
Yeah, I think it's closely connected to robotics, and as we've seen in the last talk, it's really hard to do this planning and execution. Maybe for this agent in LLMs, it's easier because it's not physically, so you don't have to control it and grab it and put it. but still it's really hard in the planning to say, I don't know, let's reach out to website owners, find problems on their website and send them an email how to fix their problems. It's hard, and I think here we will see more stuff from robotics going back into LLMs, how to build state spaces, reinforcement learning. But it's really hard, what's the reward at the end? So what do you try to accomplish? And then if you need 1,000 demonstrations for your LLM to do this, and you still get like these pure performance of like 13% or so success rate, it's maybe not sufficient. So maybe it's nice in academia when in a research setting, but for people to say, hey, you have to do it like 1,000 times and then the model can do like 13 times correct, people are not too happy about that.
Yeah, so if I understand correctly, the question is sort of just, how might we see agency emerging amongst models, and maybe with the perspective of LLMs, how does that compare to RL? So I can maybe give a bit of a personal perspective on this. So when I started in the field, I did my master's the year that AlphaGo happened, and we were lectured at the time by the Deepmind researchers who were working on it. And I remember they had this one slide at the start of the talk that said RL equals AI. And they said, they were trying to motivate, like, why should you want to work on RL? And I think there was a consensus at the time that if you wanted to get to AGI and you wanted to build, systems that could reason and act, then reinforcement learning was the way to go. And I think that consensus is much less clear now. And I remember, and this is still controversial in academia. So I wrote a blog post about 9 months ago, a year ago, pre-ChatGPT, so I guess before November, about kind of the emergence of agency in large language models. And a very famous researcher quote tweeted me and said, like, I can't believe there are serious researchers who think like this, right? Like it's still quite controversial. And I think that there are now people putting LLMs into systems where it looks like it has some form of agency. It's still pretty weak. So concrete examples that I've seen that work well are things related to like search and retrieval augmented systems where the model can take multiple goes rather than one go at search, right? That's a pretty limited agent. Chat is a very limited example of an agent. The OpenAI code interpreter is quite a limited example of an agent. We have a lot of people who have tried to build more complex agents on Humanloop and evaluate them, and the success rate in practice is really low. And the trouble is that it's hard to get very high reliability at every step. And then once you stack together a large number of unreliable things, right, the probability of like success in the final outcome goes down a lot. So LLMs seem to exhibit some degree of agency, I think, more than anyone expected, but still really hard to get it to work in practice.
I'd say maybe controversially, RL might not even be needed. So if LLMs are really good at reasoning, and they seem to be, you can just ask the LLM, do you think you've accomplished a task? And it's very likely that in the future, it will know whether the task has been accomplished or not. So
I just add to that spicy take that my personal experience across the last, 7 years is that every time I've worked on a project, like removing the RL has made things better.
Exactly. So I would agree. I would hope that's true. It's not true yet. So I'll give a counter example. I agree in sentiment. Like I really wish that was true in every case. But at least for control, there are situations where it's just impossible to get there. So far, we don't have solutions that are better with any kind of technique or even teleoperation, right? Than an RL agent, unfortunately. So, for example, the 13% example, if you gave it to RL and you just kind of gave it unlimited time, and it would probably like get 100%, right? Well, if you tune it well and all that stuff. But yeah, we're not there yet, I think. At least for control.
All right, so let's do one sort of final quick round. Are you, after this workshop, more optimistic or less optimistic about the state where we are today? I think we've heard a lot of challenges. And what is, in your view, the most important challenge to work on?
Context. Context, I think, is like being able to just have more context becomes a lot more important as you're dealing with a lot more modalities. Somebody mentioned tactile earlier, or like, a lot more images and things like that, just to give you context. Gato, in this particular case, RoboCat, uses 3 time steps as context because that's all it fits. So being able to kind of solve that would really help, at least in the robotics domain.
Trustworthiness, efficiency was already mentioned. So to be able to reduce the footprints of these models, and humans, in the sense that people should be better educated about what they should use the models for and what they should not use the models for?
For me, it's like how to quantify if you don't know it. So that's like really strong skill for a human, that if you ask me something and I don't know, I say, sorry, I don't know. I could look it up and check it. But I have like a really good calibration, like what I'm confident on, what I'm not confident on, what I can refuse. And this is with LLMs terrible. If I ask them, hey, which bands is playing at Transformers at Work 23, they will hallucinate stuff because they don't have the knowledge. They don't know that they don't know it. And so they can't refuse it. And I think for a lot of these tasks on like agents, planning, you need to judge, like, is it correctly answered yet? Is it still something missing? And is there some aspects which you don't know? So it can be like some abbreviation. So what does GPT stand for? If you don't know what it stands for, you can search for it, retrieve it, get the information, and then you fit it into your context, and then you can go ahead. But before we solve it, and that the model can really confidently and well say, what do I know and what do I don't know? I think there will be little progress on agents.
So last year we were here. We were fascinated the few shot capabilities of GPT-3 was made public via an API. And then this year we're working on these tools with multiple agents. There are some news that people were, I think Chinese researchers were playing with this software engineering factory, that there is a ChatGPT CEO, ChatGPT writer, and so on. And we are now talking about entrusting our lives to these models and discussing the impact. So maybe I'm too optimistic how they will work. And I think in the future, it's actually, I'm more troubled with the impact that it will have in the general society. And it seems that there's a bit of denial amongst ourselves. Like if we see the demo outside, GPT-4 is coding. It's coding way better than what I can do. It doesn't know information retrieval like I do. But then maybe GPT-5 will know. And we're kind of, let's forget about a little bit about this. So I'm more worried about the societal implications of this than probably technical aspects. There are a ton, I agree. But how long will take to solve? Yeah.
From my side, I'm very optimistic that we'll manage to deal with multimodal data, of course, and expand the reach. I think there's like huge potential for applications and support. I think that will be pretty impactful. I think one challenge that I've seen across different talks here is also the need for data, high quality data, also for evaluation. But also train models on beyond like simulations or like toy examples. I think to actually use it meaningful, then we need that as well.
Thanks. Before I answer this question, can I just ask Nils a question? Because I was kind of curious, you know more about this than I do. The GPT-4 and Anthropic papers, like when they do sort of empirically assess the calibration of the base models, it seemed to be quite good. And it was sort of RLHF that seemed to mess it up. And I was curious, like, am I trusting too much of their results, basically?
I'm not an expert on generative models, so I try to stay away because evaluation is terrible on that. So I like ground truth. So what do you mean with calibration?
So Anthropic has this paper titled "Large Language Models Largely Know What They Don't Know," in which they basically ask it a bunch of multiple choice questions and other questions, and then ask it to assess its own confidence and then do the calibration plot. So what fraction of the time, if it says it has 25% confidence, does it get it right? When you plot that graph before RLHF, after RLHF, it's terrible. But before RLHF, it's a straight line. And that was the same in the GPT-4 paper as well.
So I'm not convinced by that the model knows what it doesn't know. It, again, depends like on how do you benchmark it. You see it with GPT-4, you put in like some fake disease and you say, okay, what's symptoms of this?
But that has to do with the reward function that you give it, right? So yeah, I also don't know the details of this paper, but it doesn't surprise me that if you give it a reward function like the human satisfaction, well, some proxy for that, yeah, that then you lose that capability. Yeah.
not sure on that. So yeah, it's producing this fake information on it. The challenge is like, is it really a token you don't know, or is it really rare? So it can be, let's say, company names or person names can be really rare, and then it assigns low confidence. Like when I say, okay, I called my son, I don't know, and then I pick some really rare name. It's like, it gives like really, really low confidence because this combination of name is like really, really rare. And then if I say, okay, my son is called, I don't know, John Miller, it gives like really high confidence for it because John Miller is like a really high or a really common name. And so it can't decide, well, we as humans can say, yeah, that's an unusual name, but it's okay. And this is a usual name, that's okay, both is okay. But it's not really able to refute it and say, okay, this is like unlikely to be correct, or I don't have knowledge on this.
All right, I'll finally answer the question I was actually asked. I'm extremely optimistic that we will solve the technical challenges. But also I would just say that even if we didn't, like compared to where we were a year ago, I feel like we're well into the stage of things having crossed the boundary from like research to being practically useful. And so even if there wasn't further progress, I'm extremely optimistic about what people will build in the next year.
I really liked your comment in the preparation where you said the current state of the art is not overhyped, it's actually underhyped.
Oh, massively underhyped.
No.
I think that was a good thing to end on, but I guess I'll say that I'm also super optimistic. Something that hasn't been mentioned, I think is quite important, is working on maybe adding some sort of common sense priors to this model. So I'm thinking more geometric priors, thinking of vision language models. So sometimes some of the mistakes are not very intuitive. So understanding why models make these kind of mistakes and introducing these common sense priors would be really interesting. Thanks.
All right, so thanks for making these kind of predictions or forward-looking statements. We will not hold them against you, certainly not after we mingle them with a little bit of beer. Let's give the speakers a big round of applause.